All right, so this is CSC161. The topic that we're taking a look at is recursion. This one is a recursive set of commands that should sort cards into order. So this is just a recursive sort. We've looked at other sorts in the class already, so here's a very different one. All right, so you're looking at those commands. Notice each time you keep one card, the smallest card, and hand the rest down, so that's your recursive call. The code will pause at that point until it gets a response back from the code it called. And so you hand down one less card, and then it finds the smallest card, calls itself, hands down one less card, keeps going on until I hand one of them only one card. At which point then I hand back my card face up. Okay, so this is how it's supposed to work. Let's see, let me stop that share. Okay, now then I have cards and there's only 5 of them because that's all the space I've got to work with left and right. And let me just make sure they're not in any particular order. Okay. And since I'm seeing the back of the cards, of course, I have no idea what order they're in. And if you believe that, well, never mind. Okay. All right. So anyway, but they're in some sorted order. So the first thing I do is call a copy of that code that I was showing you. And this is place cards in order. So I'll do that. The first thing it says for it to do is to accept some cards. And so I give it some cards. And it says, do you have more than one card? Yes, it does. Okay. Find and keep the smallest card. Okay, so at this point, I go through and just physically look. If we were writing code on this course, then you would have to be going through an array, but that's okay. There's my smallest card. So I'm going to leave that. And it says, okay, hand the remaining cards to place cards in order. So I go get a fresh copy of place cards in order. First thing that it says to do is to accept some cards. Okay. Now then it says, do you have more than one card? Yes, I do. All right. Then find and keep the smallest card. In this case, it's going to be 2. Did those wind up? I don't know if those are. But anyway, that's okay. It doesn't matter if I shuffle them each time I do this. Okay, so it has kept one card, and it says hand the remaining cards to. Okay, so I go get a fresh copy. And the first thing it says is to accept some cards. And it says, do you have more than one card? Yes, I do. Okay, find and keep the smallest card. Okay, in this case, that's going to be the 3. Okay, so I find and keep the 3. And then it says, okay, now then, hand the remaining cards to place cards in order. Okay, so there's a fresh copy. I hand the cards to place cards in order when it accepts them. And just to pause here, at this point, I have 1, 2, 3, 4 copies of this code working. If we had 1,000 numbers, then at one point I will have 1,000 copies of this running. You can run out of memory pretty quick if you're doing it this way. But anyway, this is just illustrating. Okay, now then, so accept some cards. Do you have more than one card? Yes, I do. Find and keep the smallest card. Okay. Now then, hand the remaining cards down to place cards in order. So here is a fresh place cards in order, and I hand it a card, and it says, okay, accept some cards. Done. You have more than one card? No, I don't. Okay, then this is what you do. You hand your card back face up to the one who called you. Okay, so here it is, face up. All right, at this point, this code is finished. The memory space is released. Okay, this one has been waiting where I handed the cards down. It says, okay, receive some cards back face up. Place your card face up on the cards you received. Okay, there we go. Now then, hand the deck of cards back to whoever called you, which is this one. Okay, so I hand those back. This memory is released. Okay, place cards in order. This one's been waiting. It receives some cards face up. place your card face up on top. Okay, I've done that. And the deck back. Okay, and that memory is released. Okay, now I'm working with this one, and it says, okay, it's been waiting. It says receive cards back face up. Got it. Okay, there they are right there. Place your card face up on the cards you received. Okay, then hand your deck back to the one who called you. That memory was freed up. Now then we're down to the original call. It says waiting. Okay, I'm through waiting. Receive cards back face up. Done. Place your card back face up. Done. And the deck of cards back face up to the one who called you, which is me. That memory is freed up. And I am left now with the cards in order. Now, when it's not COVID time, what I usually do is have enough cards for every student in the class and give every student in the class as needed a copy of the instructions. And at one point, if we've got 20 students in the class with 20 cards, we wind up with 20 copies out there running around. Again, the downside to this is you can run your machine out of memory if you have too much that you're asking it to do. What happens then? Well, then it starts parsing stuff off to a storage RAM, and with that's too full or you don't have that fancy machine, it just goes and stores on the disk itself. So slows down. Now, some of the languages have built in a particular guard against what happens if you forget in your code to say, take one card. And so you forget to take the one card, you're handed 52 cards, 5 cards, whatever it is, you call and you hand down those same 5 cards, and it hands down those same 5 cards, and then this goes on forever. And you can eat up a lot of CPU time that way. Most of the operating systems, well, all of them nowadays, are set up against such a thing happening. And as a matter of fact, in the 119 class, if you took that class with me, we ran this same kind of exercise, and we're doing it in Python, and we tested, and it was somewhere around 827 times that it let it go before it just killed it off. So the danger of doing recursive code is not getting it right, and it is endless at that point. And machine really doesn't appreciate you if you do that to it, so you can get it right. But this is a different version of sorting that we can use, and it's just a recursive sort. All right, questions about that? No? Okay, then I'm going to pause the recording, if I can. Oh, here it is. Well, I'll just go ahead and stop.